Hi, we're going to be solving some system problems, and we are also going to jump into systems of three equations. So first, we need to review from Algebra 1b our systems of two equations. So again, if you haven't picked up your notes, I hope you will do so soon. You may want to pause things to write down these steps. So I have some focus questions here for us to do together. All right, so let's get this. So remember that when you are solving a system that you need to get both x and y, or a and b, or whatever the letters are. So this first one is a nice, pleasant one. We don't need to multiply. We can simply add the two lines together, and the x's would be eliminated. They would zero pair out. We also add the rest together. So we have 12y, a negative 18 and a positive 18 makes 0. Divide by 12, and we see y is 0. We're not finished. We also need to know what x is. So I take one of the two original equations. I'm just going to jump in and do the first one. Negative 3x plus 4 times 0 is negative 18. Well, 4 times 0 is 0, so this is just negative 3x is equal to negative 18. Then, of course, we're going to divide both sides by negative 3, and x is 6. Let's double check by putting both variables' values into the second equation. So 3 times 6 plus 8 times 0 should equal 18. That's 18 plus 0. It does equal 18. Check, check. So my solution is 6, 0. I do not require that you show me these two lines, but that is a way that you can be sure that your answer is correct. So you have a way of checking your solution by making sure that it works not just for one equation, but this helps me know it works for the second equation also. All right, so now go on to focus question 2, and you might try that on your own first. You will need to multiply before combining those two. I will give you that much of a heads up. All right, you actually have a couple choices on this problem. You could multiply either line by negative 1 and eliminate your y's, or you could multiply the top line by 3 and eliminate your x's. Either way, we should come out to the same thing, okay? But you cannot just add things together right now. If I add things together right now, the y's do not eliminate because they are not opposite signs. So let's say I recognize that I need different signs on my y's, and so I want to multiply my second line, or you could do the first one. I'm going to multiply my second line by negative 1. That gives me 6x minus 3y is positive 30. That top line then does not need to change. And sometimes I will just change these signs if I'm multiplying by negative 1, right? I could make this plus, minus, plus. So I just took the time to rewrite it in this case. Now my y's would eliminate. I have 8x is 56. When we divide by 8, we get x is 7. I'm going to plug that in. Remember, we substitute that in to one of the first equations. So 2 times 7 plus 3y is 26. So that's 14 plus 3y is 26. Take away 14. divide by 3, and we get y is 4. I'm going to double check by plugging both those numbers into the second equation that I haven't used, not the one I just used. So negative 6 times 7 plus 3 times 4 should give us negative 30. Negative 42 plus 12 is indeed negative 30. It works. And I could just do that in my head. I could just type that in my calculator to check, but doing the check is a good idea to make sure that your solution is correct. So let's look at that same problem, but perhaps instead your inclination was to get rid of the x's. I said at the beginning there's more than one correct way. So in this case, I would still only have to multiply one line. If I wanted to eliminate x, I would multiply that top line by 3. 6x plus 9y is 78. Remember, we have to multiply all the way across the equation, not just the x and the y. Second line doesn't need to change. Now I can put those together. X's eliminate. I get 12y is positive 48. When we divide by 12, we get y is 4. Now, if that's what I do, I have y first. Notice if I find y, I plug it into y. If I find x, I have to plug it in to x. So then 2x plus 3 times 4 is 26. 2x plus 12 is 26. Subtract 12. 2x is 14. Divide by 2. X is 7. So 7, 4 is our same solution that we got doing it the other way. So whether you eliminate x and find y first, or you eliminate y and find x first, our final solutions, if we've done it correctly, are going to be the same. All right, so focus question 3, go ahead and give that a try, and then I'm going to work it out. You might pause me. I'm going to work it out one way, and then just know that if you did it the other way, we should still come out with the same final answers. So please feel free to pause the video and try it yourself. Presto, there's my work and my solution. So I multiplied that top line by 2, put things together, got y is 3, plug that into the top original equation, got x is 1, tested it by putting 1 and 3 into the second original equation in the system. Because remember, to be a solution to a system, it has to be true for both equations. All right, so if that's not clicking, then you may want to contact me to get some extra help. But hopefully that rings a bell. So far, we've only had to multiply one equation, not both.